Hello everyone. I want to give you a quick video which summarizes the trigonometry that we are going to use for quantitative physics. This really summarizes everything that we need to know about trigonometry for the application of physics. So first of all, let's have a quick vocabulary go through. So trigonometry, now this just means triangles in ancient Greek terms, and this means measure. So trigonometry simply is a method that we're going to use to relate angles to sides of triangles. And this picture here, basic trig, essentially summarizes everything that we need to know to do well in physics class. And also a good thing about physics is that we're only pretty much for dealing with rectangle triangles. And for rectangle triangles, apparently we have one angle which is 90 degrees, so which I highlighted here. And then you have other two angles. Now we all know the three angles of a triangle add up to 180. So this theta and this one, they will add up to 90 degrees. And there is also another property. So the length of the side usually it's a proportional, not proportional, but correlated with the angle. So if the angle is bigger compared to the side, which opposite to other angles, it will be longer. Okay, so and the most lengthy side for rectangular triangle would be the hypotenuse side. Now we have two shorter sides. If we're looking at this angle theta, then the side which is opposite to this angle theta, we call it opposite side. And this adjacent side, which is adjacent to this angle. So we have for rectangle triangle, we have the red angle here, which is essentially 90 degrees. And then we have this angle theta, and this one is called theta 2. Okay, so theta plus theta 2 would equals 90 degrees. And then we have, if you're looking at angle theta, we have opposite side here, adjacent side here, hypotenuse side here. And what we need to know is that for the angle theta, we have sine theta is opposite side over hypotenuse. Now it will be opposite side over hypotenuse, which is sine theta. And then we have cosine theta, which is adjacent side over hypotenuse. And tangent theta is opposite side over adjacent side. So if you do the math, you'll find tangent theta also equals to sine theta over cosine theta. There is another theorem aside of the definition of sine theta, cosine theta, tangent theta that we need to know, and then we call it Pythagorean theorem. Now, the Pythagorean theorem states that opposite side square plus adjacent side square equals hypotenuse. So there are non-magic letters that help us to remember the definition of sine, cosine, and tangent. So we have sine is opposite side over hypotenuse. And then we have cosine is adjacent side over hypotenuse. Tan is opposite side over adjacent side. So pretty much this summarizes what we need to know about trigonometry. But there's the reverse definition I do want to bring out, that you can also using the ratio of sides to find out the angle. For example, if you don't know the angle but you know the length of each side of this triangle, you can also find out the angle. For example, this theta. If you know opposite side and the hypotenuse, then you can find out what will be the angle of this triangle. So the definition through this is that you can have theta equals inverse sine of opposite side over hypotenuse. I will just write opposite sides as O, hypotenuse as H. Then you can also calculate it as inverse of adjacent side over hypotenuse, inverse cosine of adjacent side over hypotenuse. And then you can also have, using the definition of tangent, the inverse tan of opposite side over hypotenuse also give us this angle theta here. Okay. Now there is another indication of Pythagorean theorem that we might use later in this class. We have opposite side square plus adjacent side square plus hypotenuse square. So opposite side square plus adjacent side square equals hypotenuse square. So we have opposite square plus adjacent square equals hypotenuse square. So actually we can do a trick. So if you have an equation, you divide the same number on each term of this equation, the equation would hold. So we have, if you divide h squared, which is not 0, to each side of a equation, what do we get? You see, opposite side square over hypotenuse square, it will give us sine square from this equation. See? So it's sine theta square plus cosine theta square. So adjacent square over hypotenuse square give you cosine square. Now h square over h square, of course, gives us 1. So we have sine square theta plus cosine square theta equals 1. This is the identity that we might use. Now let's do a few examples. So let's look at the triangle on the top. So we have a triangle which is we only know the sides, the length of each side of the triangle. Now in physics class, of course, if you have a size unit, we need to have units for that. So if it's 3 centimeters, then you have 4 centimeters, 5 centimeters. But here, let's take the liberty just to have the number. But we should keep in mind those 3, 4, 5, they should have the same unit. Okay, so we want to find out what would be the sine, cosine, and tangent of this. Let's see, we look at this angle. Let's call this angle theta. So we have sine theta. If you recall from the definition, Sine theta is opposite side, which is 3 over hypotenuse, which is 5. Okay. Cosine theta would be adjacent side over hypotenuse, so it's 4 over 5. And tan theta would be opposite side, which is 3 over adjacent side 4. Okay, so this is for the triangle on top. Now we have another triangle down there. So we know 3 sides. We want to know the sine, cosine, tangent of this angle. So we have, from the definition, sine theta equals opposite side over hypotenuse. Cosine theta equals adjacent side over hypotenuse. And tan theta is opposite side over hypotenuse. So pretty easy. Now, if you know the size, as we said, if you know 3 sides, you can also find out the angles. And for these 3 sides, we're pretty sure it's a rectangular triangle because we can verify through Pythagorean theorem. So if the Pythagorean theorem holds, it's got to be a right-angled triangle. We can check 3 square plus 4 square equals 9 plus 16 equals 25 equals 5 square. So this hold. Okay, check this one again. So 5 square plus 12 square equals 25 plus 144, which is 169, and if you use your calculator, you'll find it is 13 square. Okay. Now another example, we can also find angles from the side. Okay, because we already know. So we already know that sine theta, let's see, we have 3, 4, 5 for this triangle, that's for the sides. So you want to find out what's this angle. So you have sine of this angle equals 3 over 5 equals 0.6. Now what you can do, you can, in your calculator, you find the inverse sine function and you do the inverse sine function. So inverse sine of 0.6 will give you the right angle. Now of course, on your calculator, you need to know there are 2 units for angle. For this one, you need to put your unit into degrees. Now if you do this on your calculator, inverse sine of 0.6 on your calculator you find is 36.8. Actually you will get 869, I think. But let's round it up to 36.87 degree. Now you don't have to use sine, you can also use cosine because you know 3 sides. Cosine would be 4 over 5, 0.8. Now you do the same, inverse of cosine, 0.8, which would also give you 36.87 degree. And you do the same for tan, it would be 3 over 4, which is 0.75, which gives you the angle. If you work it out, it's also 36.87 degree. Now I will leave this as a practice to you to find out this angle. Now I will say you need to practice, and also let's call it theta 1, let's call this one theta 2. practice to find theta 1 and theta 2. If you're familiar with subject, you don't have to do the practice. Now let's look at those two examples. So we have two triangles, and of course both of them are rectangle triangles. For each of them, we only know two sides of it, and we don't know the other side. But we can find it out very easily using the theorem we just talked about, Pythagorean theorem, if you remember. So we have 6, 8, and then we need to find out the hypotenuse. So simply we have x squared should equal to 6 squared plus 8 squared. This is 60. This is 36 plus 64, which gives us 100. So x should be 10. So you have 6, 8, and 10. Now for the second one, in the bottom, we know hypotenuse. We know adjacent side 8. We don't know why. But still, we use Pythagorean theorem. 8 squared plus y squared equal 12 squared. So y squared is 12 squared, subtract 64, 144, subtract 64, which is 80. If we know 9 squared gives us 81, so square root 80 must be awfully close to 9. And my guess is 8.9 something, but if you put it in your calculator, you would find y should equal to 8.94. Now, if you only know one side and one angle, now actually you can also find out the other sides and the rest of the angles. Now apparently if this angle is 51, then this angle is, let's say, 39, right? 39 plus 51 give you 90. And you know one side, which is 10. You need to find out what is hypotenuse, what is adjacent side of this angle 51 degrees. So let's first find the hypotenuse from the definition. Opposite side over hypotenuse give you sine this angle. So sine 51 equals 10 over hypotenuse. Now hypotenuse should equals 10 over sine 51 degree. Now if you put it in your calculator, you should find 12.87 if you round it up. Now the same way, if you want to find out x, now suppose we don't know hypotenuse yet, we just know this 10 and this angle 51, so it should be opposite side over x. So 10 over x into, now this equals to 10, 51 degrees. So you can calculate x as 10 equals 10, 51 degree. And if you carry the calculation out, I'll ask you to do this as practice. Okay. Let's just exercise one more involved example. Now, I don't think you're going to get any problem that is as difficult as this one for trigonometry in my physics class, but just want to present it to you. I think it might be more helpful for some of you. So this is a realistic situation. We want to measure the height of a wall, and it's very muddy, just down the wall over here. So they measure the distance, which is 45 meters, and now we know this angle is 30 degrees, this angle is 50 degrees. So using this information, the information that we have here, from here to here is 45 meters, this angle is 30 degrees, this angle is 50 degrees. We want to find out what's the height of this wall. So you see, if we know distance, if we already know distance, so we know distance. This would be the adjacent side of 30 degrees. Now this one, let's call this one x. Call this one y. So actually x and y are related. We should simply have y equals 45 meters plus x. And from trigonometry, we should have tan 30 degrees equals h over y, which also equals h over x plus 45 meters. And then you also have tan 50 degrees equals h over x. Now see, we have two equations, and equation 1 and equation 2. We want to solve for h using these two equations. It might look intimidating at the beginning, but now in this one we can make it simpler. So equation 1 can give us h equals x plus 45 meters tan 30 degrees, and 2 can give us h equals x times tan 50 degrees. So now you find out they are both h, so they should be equal. So you have one. Now this time you have one equation, x tan 50 degrees equals x plus 45 meters tan 30 degrees. So you have one equation with one unknown variable, x. So you can solve for this one, you can find out x. Then after you find out x, you just plug your x back into equation 2 here. So because if you already know your x, you can find out what's h using the x you already got. So that's all I want to talk about for trigonometry, and I hope it will be helpful for you guys. So if you are not familiar with trigonometry, please do some exercise for yourself, the homework programs and the quiz I posted on D2L. If you're still having trouble, you're more than welcome to stop by my office. We can discuss it. I think I can help you more on this. I really don't want the trigonometry to be the barrier between you and me and the physics. Okay, thank you, and I will talk to you in the next video.